Well, hi, good morning. Thanks so much for joining me here in my shop. It's been a few days since I've actually done any work on the radio. Last time I worked in here, I worked quite a while and I ended up producing 2 or 3 videos out of it. So that's why I've been taking a few days off. In the meantime, I've been doing a little more research, and I want to thank a few of you for sending me information. It's very helpful. Saves me from hunting around, and often, what I do is first thing I find, I usually accept as the be-all and end-all. So I'm talking about schematics here. So this is the one I've been using. This one was prepared by Supreme Publications, and they purchased one of these radios and examined it to develop this schematic. It's the one with the curious hanging open coil issue right there in the little box. Kind of still wondering where and what this is. So this will appear on the other schematics. So let's take a look at one of the other ones. Okay, the next one we're looking at, it says Philco on it. This could be Philco's own schematic here. Okay, so now if we look at that same coil, just quickly, we're not look at the whole thing, just there's that coil. And see here it's attached. It's not hanging open. So that solves that. I guess on this other schematic, they just failed to continue the wire down. So thankfully I've got this schematic that it clears it all up nicely. And if we go to the third schematic, now this is a little small to show on camera, so I'm going to look, so I'm going to hold it here in the camera anyway. So we try to find that same coil. It's right here. It's there. It's showing hanging open. I don't know if you can see it or not on camera there. We'll look at these things on the computer screen if we really need to. But now, in this schematic, the dotted line or the shield box is shown containing 1, 2, all 3 of these. And this starts making a little more sense now, because on the schematic I started with, it's in its own little box outside and shielded away from this. This is actually quite wrong. And then what about the one that shows it connected? If you look at this carefully, you can actually tell that this line was extended by somebody with a pencil. See the dot? Can you see the dot in the camera? Maybe you can't see it. The dot here is hollow in that somebody just drew a circle. These dots are all carefully drawn. They're very carefully drawn. But that one, no. So somebody took a look at this and extended the line down, and then this is a photocopy of their addition, which is wrong. Because in fact, I'm sure what is right, not this one is the correct one. This is from Sam's PhotoFact, which I believe is kind of an American deal. And so again, we're looking at the Canadian version here, which may be a little different. Probably not. So here's another issue between these multiple schematics. The IF here is 265. The IF here is 455. And the IF here is 265. Well, just on a matter of odds, I'd say 265 is probably correct. But I mean, the lesson here is, and it's a lesson for me too, and I've learned this lesson too many times. This lesson is in my head. Have doubt with everything. Doubt everything all the time. Approach all this with a huge measure of doubt. So what I'm going to do now that I've acquired another schematic to compare to the other schematics, I'm going to go away for a while off camera and study these things and see if there isn't two things that can happen. One, find out more that doesn't agree. I doubt that's going to happen. I think these are probably on pretty close agreement. But what's more likely to happen is the different way in which the schematics are laid out are going to speak to my brain cells differently, and I'm going to realize things. I'll just show you an example here before I stop recording. I complained about this schematic and why these two components here, this is basically the capacitor and resistor connection to the chassis, grounding to the chassis if you want to call it, why it's drawn over here, tucked inside this area. Well, the wire, it's really electrically connected way over here somewhere. Why they put it like that? Hide it away in there so it's hard to spot. Here's what another draftsman did. With the same issue, look where he put it. He put it way out here, way out in the boonies, where it's quite obvious what this is doing. Notice too on this schematic they've used the chassis symbol, which is much better than that ground symbol. Chassis, 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 3 chassis connections. There should be a fourth. Here's the fourth over here. So, you know, schematics. Can't live with them. Have to live with them. That's the situation. Okay, so I'm going to go study these up. And, you know, once again, the objective is to start changing out capacitors without removing any important critical ones, of which there appear to be 3. But in studying this yesterday and the day before, and studying that and this, that, this, that, this, that, this, I'm still not 100% sure who was what where and how it all works. Great, that's a good start. Okay, so just getting ready to check the 3 schematics I have, and it turns out I've got a 4th one. I got 4 different schematics for this radio. All different. All drawn by different people. Hopefully all the same, but I don't know. So here's the latest one. This is from Ryder. And this one, they've actually shown the heater arrangement. So if you're watching this video because you've got one of these radios and you're trying to do what I'm doing, then better hunt down all these schematics from everywhere. But it looks like this is the one to have. John F. Ryder. So Mr. Ryder's version looks like the best one. This will be helpful to me. And the general look, just glancing at this because I haven't studied it. Oh, so here's this mystery coil. Look how they've drawn it this time. The mystery coil is shown lined up with this primary coil. So if that doesn't talk, this talks to me. This makes sense. This says something. Whether it's in a can or not, I don't think it's in a can, to be honest with you. This is supposed to be a capacitor off this. Why? There's no capacitor drawn here. Coil. Here we go. Right up there. No capacitor. This one, coil shown connected. Not shown associated with these really. Come up over to a capacitor. This one, showing isolated away from this transformer, which is totally wrong. I think it's totally wrong anyway. Not shown connected here, but shown connected intimately to this capacitor, which is inside here. But you know what this looks like? This looks like a capacitor with a coil wrapped around the outside of it, which apparently this is a classic Philco circuit trick. And I think they used to call this the IF filter. IF filter? I better watch what I say here. So, and I got another one, last one. Okay, last one shows all 3 coils contained inside some shielded thing of some sort. This one shows the capacitor connection, but it doesn't show the coils aligned in any sensible way. It's just showing them that way for drafting reasons. So I know this isn't coming across on the video very well. So it's not so much the details of what I'm showing you, it's the fact that this is differing on every one of these schematics. Subtle differences are taking place. Anyway, I'm off to study this some more. Okay, so here's where I'm at. I'm still studying this capacitor here. Let me just show you where I'm at with it. First of all, we'll take this schematic here. So this capacitor, which I believe has a coil in it, is connected to this terminal, which is connected to this wire, which is the ground wire. This terminal I can see is bolted or riveted right to the chassis. So one side of this thing is onto the chassis directly. The other side is connected to a terminal here with 1, 2, 3 other fairly large capacitors connected to it. So where is that? So I believe this is this. There's problems right away, so let me continue. One side connected right to the chassis. Perfect. Other side, oh, there's 2 wires coming out of this. 2 wires coming out. That's where it ends, because this thing only has 1 wire coming out. Or am I blind? Let's find out if I am blind here. Okay, so here's the guy in question. Something in red there I can't read. So let's look carefully at this end. So am I missing a wire coming out of here? So I swear there's just this 1 wire here. Over the other end. This end's really interesting. If you look inside, you can see the capacitor lead coming out, and this is wax here. But this is the lead coming out, and you can assume attaching to a coil that we can assume is running underneath this cover. And then the coil exits out this wire, this one here, which you can see is not heading to the center of the capacitor, it's heading to the outside edge of, or just under this cover. So this has to be the item involved. Where's the 3rd wire? They sneak it out part way? I can't imagine it. So, you know, if now I've read that, in fact, you can rip these out of here, stick a capacitor back, forget about the coil, and you probably won't affect the performance of the radio. So again, if we look at the schematic for this guy, here's a different schematic. There he is there, okay, so it's showing in, what's that little note there? Part number 21 or 28. They got a dotted line around it, so it's a thing, and then there's 3 wires coming out of it. One going to ground, right there. That actually is the symbol I think refers to chassis, connected to the chassis there. And out the top. Wait a minute. So this wire out the top, that's one of the antenna leads, just ends with a dot there. One there and the other one just over here. Those are the 2 antenna wires hanging out the back of the radio. One of them comes in, the light colored one that confuses me, comes in. This shows it coming in to the top of the capacitor. And then there's this other side connection. This goes way over here to another one of these things. Oh, wait a minute. Okay, so this one, 0.05 in a coil, yeah, connected to chassis ground. Look at the schematic here. I gotta put this down and show something to you again. Again, it's my drafting supervision days coming out here. So if you look right in this area here, it's pretty obvious that this line here was originally drawn right across to here. You can see remnants of it. I can see it better with my own eye. And then the draftsman, I guess this was an error, he brought a new line down and drew it through here, erased this and put the hop in, and then he heavied this whole thing up because he had a heavy hop here. He decided to heavy up this line to try to make it all match, and this new line here is heavy. And he didn't make a good show of it here. So at one time this schematic had this error in it. And it's right, so this is probably the one I'm pointing at. This is probably, because it's only got 2 wires. Well, thank God I solved that. So that's this one, which is also, well wait a minute, it's connected right here. Whoops. It's connected between these 2 resistors. Okay, so I gotta follow the. Then so this one is still a question. where and what is this? the 3-wire one. So yeah, the ground. I'll do a great big capacitor here. You really got me. You got me. Oh, heater line. Oh, never mind. Too many wires. Too many wires. Too many schematics. Too many this, that, and the other thing. So I think I now know for sure. The one I'm poking at is this one in the radio. So I've gotten busy and I've changed 1, 2, 3, 4, 5, 6 capacitors, and it's time to test this radio and see if I haven't ruined it yet. Prior to starting this work, in the last couple of days, I have spent an inordinate amount of time examining schematics. I now have 4 different schematics for this radio, and they don't all add up 100%, and they're not very helpful at solving one of the problems with these Philco capacitors is many of them do not have the value written on them, and you've got to take the serial number and sort out what the value might be. Let's just say I've thrown away hours here. I wouldn't say thrown away, but I've done hours of effort. Never got me where I wanted to get to. So I'm just going ahead. I've been doing one capacitor at a time and identifying its value. I've given up on the do it in some sensible order. I'm doing it kind of on order based on where they are in the radio and what makes sense to do first, second, third, that kind of thing. Okay, now we have an antenna connected. We don't have any power on here. Okay. Yes, I was working in here, changing these capacitors, no video running. In silence, I wasn't even talking. Okay, there. Now, let's put this here. So you can't read this, I suppose, in the camera, but this brick says made in Canada, then it says think before you act. Isn't that interesting, eh? Think before you act. Even the brick's got an attitude in here, for crying out loud. There we go. Okay, looks good. This is not good here. Okay, speakers connected, volume. By the way, when I went into a panic there the other day, when the radio suddenly started working, this volume control works backwards. This is up. So that's why I went, I'm still laughing at that, by the way. Switch off. Power on. Now for sure, having changed some capacitors in here, I certainly want this to be on the dim lights. These guys here. I think only this one's in. Yeah, just this one. And here we go. Bulb good. Voltage good on the meter up here, you can't see. I almost got the volume backwards again. Let's put it on full power, because I think I discovered this radio doesn't work well on a lower voltage. It's a ton of volume. Well, it's behaving like a radio. $15 of power. Okay, so I'm going to carry on changing a bunch more capacitors, and we'll test it again when I get through that. Okay, so I got four more done, I guess. So I now have 10 capacitors changed in here. I just have these two remaining. This is the one that I'm sure has a coil. I'm positive there's a coil here. This one, you know what? I think this is just an ordinary capacitor, a fairly large one, 0.25 in fact. I'm leaving it there for now. I'm going to test the radio as it is. Then I'm going to probably change this one out and probably leave that in. I'll probably leave that one in if the radio starts working well. So, hey, I don't have to. I'm just going to stop the video. Let's just keep it going here. Okay, over you go. I also put a new power cord into it here at this point, so you can see that. The final permanent power cord. Ooh. I should have inspected that a little closer. I think that's okay. Looks like a soldering iron strike there. Not for me though. Not for me. Okay, so we don't need this here anymore. That out of there. Oops. Speaker around here. Okay. Set here. So we still have an antenna hooked up for what it's worth. Here's the other wire. There's supposed to be another. Shouldn't there be another wire hanging out there? What happened? Oh, it's up there. Okay. Ah, yes. A little late in the afternoon. Okay, now we're going to plug it in. That power's off right now. Okay. Start right from scratch here. That's off. Okay, everything looks good. There we go. Good, nothing happened. Something will happen this time. Okay, Mr. Radio, I might as well put you on full power here right away. Working, that's good. Pile of dead capacitors, dead soldiers. I'm imagining I'm hearing a voice there. What was that funny sound? Well, not picking anything up. Now, let's go after the last 25 in here, or 0.25. I don't think it's going to make any difference in the performance of the radio. And then after doing that, I will leave the coil capacitor in place, and then we'll go ahead and do an alignment on the radio, or we'll pump in some other test signals and try to get some action out of the detector. And then if none of that's working right, then I'll consider again that capacitor with the coil built on it, but I just don't think that I don't think there's any glory in changing this. That's what I think. I don't think they're going to get any advantage from it. Okay, so let me get that last capacitor out of there. Okay, we're all set for another test here. This first test will be on an antenna. We'll see what we get, and then I can use my signal generator. There we go. Everything's normal. So that's just one more capacitor I did, but it's a big honkin' 0.251. Very important capacitor. So it's just leaving one original paper capacitor in there now. Oh my gosh. If you saw me jump, I practically jumped out of my shop there. Super volume. No shortage of volume, that's for sure. Okay. There we are. Hear the voice? There's another one. City of Toronto and guns. The City of Toronto has 3.5 million people in it, so you can come up with a gun story just about every day now. Okay. So, why so garbled? Is it that one capacitor I left in there? Where'd it go? Okay, so I've lost the signal now, but that's okay. Is that because of one capacitor left in there? That's going to be the question. So I'm just hooking up to the signal generator. I never put the ground on with the antenna. Maybe I should have done that. Never too late. Let's just try to be a little more thorough that way. So antenna, ground. This is just a wire to the chassis here. It certainly changed it, didn't it? Better. So that's kind of sound I've heard many times coming out of radios. And it, I would take a wild guess. Hum in the IF shows up as a garble in the voice. I'm not sure what it is that causes that. There's one more capacitor in there. And which one is it? There, pick yourself a schematic there. Oh, that's minimal. Okay. So I believe what I'm going after is actually on this schematic shown right here. No, not that one. No. This one. 0.05 with a coil. Wow, and this is, God, what's this related to? Is this related? So this is the local oscillator. What's it? Oh, it's hooked up essentially to the antenna. Past this point, it's not hooked up to. It's hooked up to here. Bypassing this huge resistor here, 4.7 meg. It's obviously some kind of filter arrangement here, and I think this is a classic Philco circuit deal here. And on this schematic, the same part shows up there, where the guy had changed the schematic I was showing you earlier. Otherwise it's wired the same. I don't quite comprehend what this is doing. Here, the same thing is shown, not there, this is the 3-wire one. Here it is here. It says choke. 0.05, it gives the capacitance in there, 0.05 capacitor. So it's on the same line as this one. Well, so I read you can change these. You can change these and drop the choke off if you want, or you can try to rewind a new choke. Why don't I try to test this capacitor before I go any further? I'll put the capacitor tester on it. We'll see if the capacitor is good. I mean, the coil is the coil is the coil. That never changes. So we'll give the capacitor a test and see if it's worth it. Because offhand, I don't think it's worth it. I think it's as long as the capacitor is good. So let's test it with a more modern tester to start with. And if this capacitor is leaky, a tester like this is just bogus. I mean, I don't think the people who developed this tester had any vision that it would be used on parts from an old radio like this. That's not what's in their heads when they're doing this stuff. Okie dokie. So there's one lead here, which I'm pretty sure goes through that coil. That looks resoldered. That looks like an after the fact resoldering there. I didn't do that. Yes, I did. I did do that. I did do that. So it's supposed to show up as a 0.0, what did I say? 5, I think it was. I figured out it was. It was a 0.05. Okay, so we're getting a reading of 0.03. A number of the capacitors I pulled out of here to change when I matched them against the schematic, and it turns out the size is written right on most of the capacitors. I did not match the schematic. I replaced all these capacitors size for size based on what was in here. I did not follow the schematic on it. So is this really a 0.03 inside here? Does it show up on any of the other schematics with a value? Here's another schematic. Here it is down here. L2.05. Look where they're showing it down here. I mean, it just gives you a totally different impression as to what it's up to. It's tied, one side's tied to the 0.25. That's right, this, here, there. The 0.25, by the way, I had to put in 3 0.1s in here. So I have 3 capacitors jammed together to make a 0.3 instead of a 0.25. I don't have any more 0.25s. Well, how scared should I be? Why don't I cut this part out, open it up, we'll take a look at it. We'll stick it back with just a capacitor, or I'll figure out some kind of coil. I'll try to match what's in there. If if I'm going to remove this, I'm going to remove one lead off it. I can test it again much more better than I'm doing now. Let's do that. Let's do that. So I'll pull this lead off, one that's got some slack. Anybody got any slack in there? Sometimes you can rip these off the terminal. Got some slack in case I want to put it back on. So we're going to nip it right off the... should I nip it? And then we can... Yeah, I'm going to nip it in the middle. We can link it if we have to. Take it right out. No, don't take it out. Don't get yourself into trouble unnecessarily, Jim. Okay, one more look. I'm assuming the coil in series doesn't affect this. I get the same reading. 0.03. Let's test it for leakage. Let's see how leak it is. That'll settle it. Okay, so we're going to be using the my old faithful here. A couple of good leads. Okay, so this is a 0.0. You should be okay. Long leads on a capacitor checker. Can't be checking small capacitors with long leads, but this is not that small. Okie dokie. Very grippy. There we go. Okay. So we're watching the gap here. 25 volts DC placed across that capacitor, and this will indicate the leakage through it. So that indicates a super good capacitor. Do you see it pop open? 150. It's also indicating I may not have a connection to the capacitor. It may also indicate the coil that I suspect is in there may be open. I don't think so. 250. Okay, something's not right. Something not right here. Let's back this up and just try a simple ohmmeter check. I can do it with this one, I think. Of course, it's a capacitor. Well, what do I expect is going to happen? Jimmy, what are you doing? I gotta see if it sees the capacitor charging. I wouldn't say so. It's kind of weird. It could still be an open circuit here. Let's flip these around. So I'm looking for the charge up effect. Oh my God, this flipped right onto the wrong reading. Completely wrong reading. It's a little tiny dot there. Keep your eye on the dot. Okay, ohms. Let's see your charge up. Wow, as open as it can be. Okay, impression is it's open circuit, but it is a capacitor. That's funny, I can't even be sure of an open circuit here. Let's try one of my more beloved meters here. Can't see how we're going to get anything different, but let's try it. Again, I'm just looking for a quick charge up on here. Oh, on there. Is this open circuit or is it not? Open circuit. Now, I got a capacitance reading on it, but maybe that's just totally bogus. Do they get any charge up the capacitor, then look for residual voltage residing in the capacitor. Even if it's a little leaky, it should hold a charge for a little while. So what I'm going to do is I'm going to hook this up. Like so. We're on voltage now. My little short leads here. A little bit of voltage on it. And I'm going to hook up the well, if it's holding voltage and it's depleting it now, that kind of indicates, yes, there's a capacitor in there, as I imagine there really is. I just really have trouble believing there's open circuit here. Okay, so what I'm going to do, I'm going to set this to 150 volts. I'm going to hit the switch over here. It'll be 150 volts on here. I'm going to put it on, watch the meter, take it off, see if the meter drops right down to nothing really quickly. Are you ready? Here we go. 20 volt scale. Nah, there's a capacitor in there. Okay, so now we've got a capacitor in here which is measuring 0 leakage, like it's the best capacitor on the planet. 150 on there. Hey, the eye's not open. What's different here? Oh, I didn't even hit the switch. Ready on 150. Right open. 250. Oh my gosh, what's that capacitor rated for? Who knows? It won't say on there. Could put, you know, I could put another, I could put a 0.05 in there temporarily, and see if it, and forget about the coil, and just see if that doesn't clean up some of the nonsense in the radio, and then worry about. That's a good idea. I like that idea. Good idea. Didn't even bother finishing the sentence. It's so good. A 0.05. 0.05. I could practically clip it in there, couldn't I? Radio power is on. Son of a gun. Shame on me. Somebody kicked me in the pants for that. I left the power live the whole time I was fiddling with it. There was live power here. Shame, 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 shame. It's good for me to beat myself up a little bit when I make a mistake like that. Shame is a very, very valuable human motivator. I'm going to try to twist this in here enough that it's going to work, just without soldering it. I guess I could kind of lay it in like this. basically what I got to do to install it anyway. Okay, no short circuits, please. Okay, in my estimation, that's connected enough to do the test here. I have the feeling it's going in permanent. This thing hanging out. The radio, what's going to happen? I don't know. Let's flip the radio and see what happens here. Okay, antenna on, speaker on, temporary capacitor on, power off, ready, set, here we go, watch the light, and there goes the light. Now, is that garble going to be gone? Wow, I'd be impressed. I would be impressed. Trying not to jump this time. Well, I think what's next is doing an alignment, and just in case that garble has something to do with bad alignment. Once you have the alignment out of the way, if it's still garbled, then we know we got to go chasing something. And like I say, I've heard this many times in many radios, and oddly enough, I really cannot tell you what causes that. Somebody's going to say, "Oh, that's intermodulation distortion." Okay, thank you. Okay, thank you for that. That's it. So thanks for watching, and next video we'll align this guy and see what we get out of it. I gotta start cleaning up the cabinet anyway.